All right, so we got the line of uniform distributed charge. What is the electric potential at a specific point? So the first one, you had some nice symmetry there, and the second one, we did not. Okay? So it's just how to do it, or was there something more narrowed down?
It was just how to do it.
All right. So let's see, we've got a line of charge along the y-axis, an electric potential at a particular point that doesn't have symmetry. Okay, I'll use different numbers. So, line of charge. Caleb, you got a question?
I forgot to turn in my labs.
Okay, just
Sorry.
line of charge from, let's say, 0 meters to 10 meters. I've got a point, we'll just say 3 meters, 4 meters, and let's see, 3, 4, that is not, probably somewhere like there. And for the international fans, this is Caleb. Recording. You have an alibi now. It's 2:25.
Okay.
He was not at the bank when it was being robbed.
All part of my plan.
Unless you're a twin.
I might have an equal one. Yeah. Sorry about that. I'm
No
gonna
problem.
turn the lab in online, or the graph.
If the graph's not in there, then yes, online. All right, so that's still erasing. That's 3 meters, and that is 4 meters. All right, so when you're setting it up, I know basically my formula for the electric potential, KQ over R plus some constant. But we established in there, at least in part A, that if R is equal to infinity, the constant has to be 0. So if R is infinity, so we get KQ over infinity plus some constant is equal to 0. Well, that's 0, so the constant has to be 0. Patrick, you have the look of, there's a question about something I've written? Okay. So I know the point charge formula here, but I don't have a point charge. I have a line, so I have to create a point charge, and so I create one, dq, and I need to find the electric potential because of dq. Well, this is my distance r. I know this is 4 meters. Sorry, that is 3 meters. And y is, if I started at 0, that's my y right there. So if that's 3 meters, r is going to be the hypotenuse of this right triangle here. Well, this is going to be, well, that's 4 meters. This is y minus 4. So if I'm above the axis, I'll get a positive. Above my point, I'll get a positive value for my vertical distance. And if I'm below, I get a negative one. So I know, therefore, that r squared is equal to y minus 4 squared plus 3 squared. And so I'm going to integrate my k dq over r. This is my point charge, is dq. K is a constant, so it comes out. I need to get q. I have 2 variables here. I need to get them in terms of the same variable. Well, if this is a uniform charge distribution, then I know that my linear charge distribution is q over the total length, or dq over dy. So dq is equal to q over L dy. So that's gonna go in from dq. I still have two variables, I got y and r now, but I have a relationship between r and y right here. And so I've now broken this down into k, big Q over L, integral dy over the square root of y minus 4 squared plus 3 squared. So if I do, and then at this point, that's a math problem now. I think you end up with a natural log of something.
For A, I did as well.
If we do a little u substitution, let u equal y minus 4. Unfortunately, my y's and 4's look too much alike, but that's where we are. We'd end up with kq over L times the integral of du over square root u squared minus 3 squared. That's something that would be on one of the tables. And go. Squared. That is natural log of, not that one. Is that, there we go, natural log of u plus the square root of oh, that should be plus. Did I mess up over here? No, I have plus over there, I just messed up here. Over 3 squared plus u squared. Okay, the limits of integration, well, y goes from 0 to 10. So that goes from 0 to 10. And so u goes from -4 to 6. Questions?
That's a different Y, right? Or,
I use different numbers in the problem with the master set.
no, but Y is, what part of the line is Y in that?
I had y going from 0 to 10 here, and I think in the master set, it went from 0 to 8. 6 going from, yeah, from 0 to 8. I went from 0 to 10. So y is, well, if y is equal to 0 here and 10 there, y is going from 0 to 10. That's a u over there. I did the u substitution just to get it into this format, which you're more apt to see in a table of integrals.
But Y is R squared equal to Y minus 4 squared. When, that would only make sense if Y ends at the top of the charge, right, of dq.
So y is from here to here, but this part of the hypotenuse is, since that's 4 meters there, this part of the triangle is y minus 4. Because y is from here. Bizarre. All right, I'm missing the question.
So you found the limits of integration because you said Y is 10 meters.
Because my line of charge goes from 0 to 10 meters.
Yeah.
So my Y value, since Y is defined at, starting at 0, it goes from 0 to 10. That's how I define my limits of integration for Y. All right, I'm still missing.
Well, R squared equals y minus 4 squared plus 3 squared,
Correct.
and y minus 4 is, why is it y minus 4?
All right, so let's clean this up. So I've got my line of charge here from 0 to 10. I have somewhere around here is my point in question where I'm trying to find the potential. I know that this distance here is 4 meters, and this distance here is 3 meters. That was the problem that I gave on the board. I need to figure out, so if I have my differential here, if that's my differential dq, I need to know that distance there, that's my r. R is from my point charge to the point where I'm trying to find my potential. So I have a triangle here. That triangle, I know that my base here is 3 meters. That's r. This distance right here, the distance from here to here, because that's part of the triangle, that's the part I need. Well, y is defined here. Y goes, that's my y.
Oh, I see.
This is 4, and so this has to be y minus 4.
I was just confused because you said y is equal to 10, but that's just a different y.
Well, the 10, that would be at an extreme y is equal to 10. But generically, it's gonna be y minus 4, where it's 6 at the most, this is the 6 at the most, and negative 4 at the least.
Would it work if you just split this into 2 problems, 2
Okay.
integrals?
Yeah. I assume from here up and here down? Yep.
Okay, that makes sense.
Okay.
Okay, because when y equals 0, it would be negative 4, okay. Thank you.
Yep.
Sorry, I don't know why I was so confused.
Other questions? Okay. Without other questions, I say let's do the lab. We'll be heading down to the other room. The equipment should already be out, except for that, whatever I missed. I don't know. And Emily, time to move.
Dr. Fox, would it be okay if I get my master's